Okay, copy down this warning and this example. Okay, so in R3, which is where we're going to go eventually, this equation here no longer represents a line. It actually ends up being a plane. So I'll remind you of that, but something to keep in mind. Okay, example. Let's see how we can convert from normal form to vector parametric form. Okay, in the preceding example, I showed you how to take vector parametric form and eventually arrive at normal form. And now we'll go backwards. So I'm going to take this equation, solve for y. It doesn't matter. You can solve for either variable here, but I'll choose the one that's more available. And what I'll do is I'll put this into a vector xy and see what arises. If I pull this apart, I get 0, 5 plus x times 1 minus 3. And if I let x equal t and recopy this and this, what I get is what I want. Here's what we're saying is for a vector xy to pass this test, it must also pass this test. Okay, another example to chew on here. Now we have two lines in R3. Okay, there is no normal equation for a line in R3. There is no normal equation for a line in R3, but there is still the vector parametric equation. Point of intersection. Sorry, pause and copy if you haven't done so already. Point of intersection. So what I'm going to do here is just equate. I'm going to say if I want a vector that's on both of these lines, well then this vector here should be set equal to this vector here. Almost. There is a little snag here. Okay, now, what do we mean by a point of intersection? We're looking for a vector x that can be written this way and can also be written this way. However, it is not required that they share a t value. Okay, so if you can be written this way, that means you are on this line. And if you can be written this way, if you can be written this way, that means you're on this line. Okay, but I don't need this t value to be the same as this t value. That's not required. So what I need to do here is scratch out this t and use a different letter. Doesn't matter. I'm going to use a S. Customary to use an S there. Okay, so I hope you agree that logically I don't need the parameter here to be exactly the same as the parameter here. Okay, what do I get? I get three equations. First equation is 1 plus 3t is equal to 16 plus 3t. S. 4t is equal to 20 plus 4s. Negative 1 is equal to 14 plus 5s. Put this into a matrix. Why not? Let's. So I'm going to skip some steps here. I'm going to move. Well, I'll just move everything. I'll move these two t terms over here, and I'll move these constants over here. So for my s column, I'll have 3, 4, 5. For my t column, I'll have -3, -4. Oh, this wasn't necessary, was it? Oh, well, I'll just do it anyways. 0. And for constants, I will have -15, -20, -15. I guess I didn't need a matrix here. I have such a simple equation here that matrix wasn't necessary, but oh well. So what do I get? To get 1, 0, -3. Put this line here. I'm not being consistent. Well, you can put the line there or not put the line there. It doesn't matter. And divide by 4. 1 minus 1, 5. 1 minus 1, 5. Minus 5. Minus 5, sorry. So just reducing as you, I guess I'm doing this in a weird way, but if you don't follow what I'm doing here, you just take it aside, do it yourself. So I find that S is equal to -3, T is equal to 2. And I'll plug that, I'll take this T and plug it in here. To find the point they have in common. So what do I get? 7, 8, -1. And you can write that as a vector or as a point. Doesn't really matter. So that's my answer for part A. Now, part B, have I given myself any space? I have not given myself any space. What is the angle between these two lines? Well, the idea is you have where was I? You have these two lines, you have like whatever, L1, L2, and you have the smaller angle between them. Now, if you think about the direction vectors for these lines, if this is the origin, then the direction vector for L1 will go like this. The direction vector for L2 will go maybe like this. And you have the same angle down here. So direction vector for L1. So what am I saying here? I'm saying that the angle between these lines is the angle between this direction vector and this direction vector. So I'll write that as I want the angle between 340 and 345. And I'll leave this to you as an exercise. And the answer is pi over 4.